Good morning, students. Good morning, students. Am I audible?
Yes, ma'am.
All
Good
right.
morning, ma'am.
Good morning. So we'll start after the prayer. Okay, I'm going to play it now.
ॐ श्रीगुरुभ्यो नमः हरि ओम् ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्युषावहै ॐ शान्ति शान्ति शान्तिः ॐ असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्यो मा अमृतं गमय ॐ शान्ति शान्ति शान्तिः ॐ सर्वेषां स्वस्तिर्भवतु सर्वेषां शान्तिर्भवतु सर्वेषां पूर्णं भवतु सर्वेषां मङ्गलं भवतु ॐ शान्ति शान्ति शान्तिः ॐ लोकाः समस्ताः सुखिनो भवन्तु लोकाः समस्ताः सुखिनो भवन्तु लोकाः समस्ताः सुखिनो भवन्तु ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः ॐ श्रीगुरुभ्यो नमः हरि ओम्
All right. Good morning, students. Could you hear the prayer properly? Yes, Priya. Was it audible?
Yes, ma'am.
Prayer was audible, right? All right. Okay.
Yes, ma'am.
Okay, students. Yes. So, so we were discussing about, big O notation, right? So now we have actually seen some of these concepts. So again, we are in the revising mode. So let us now define big O. Okay. So what is big O? So big O of Gn is a set of functions, right? With this definition, wherein we say that Fn is big O of Gn. Or if it is given that O of Gn, what is the meaning of O of Gn? O of Gn means we have a function Fn such that we have another function Gn, right? And we say that Fn is big O of Gn if there exists positive constant C and N0. Both have to be positive constant, C and N0, right? The positive constant means they cannot be negative, right? Such that 0 is less than equal to Fn is less than equal to C of Gn, right? So basically Fn is less than or equal to C of Gn. And for all n is greater than equal to N0. Right? So the important thing is N0 and my C constant should be greater than 0 basically. Where when we say here positive constant, they have to be greater than 0. Okay, so all of you know this definition. So what exactly this means? This actually tells that big O gives us an upper bound. So we can bound the function fn above by some constant factor of gn. That means fn cannot grow more than gn with some constant factor. So important for us is to find this constant factor, right? And another thing is it actually gives you a increasing range, that this minimum n0 should be this much minimum, after that beyond which, so when n is equal to n0 or more than n0, this condition should satisfy, right? So important for us is to find out c and n0. So for example, big O is upper bound. So again, the definition is same. Now these are some examples. Let us try to understand them. So we are saying that O of n square, Gn is my n square. Okay, Gn is my n square, and what all Fn are possible. Okay, if you see it other way round, then can I say that for all these Fn, Gn is going to be On square? The answer is going to be yes, right? So if f1x is 3n square, I am able to find a c and n0 such that this condition satisfies, right? So f1x is 3n square, it is going to be On square. It is half into n square. It is not 1 by 2n square, it is half n square plus 100. This is n square plus 5n plus 40. You know that it is On square. Now this is written here 6n. Right? All of you will say that it should be big O of n as per the rule, right? But if you say that whether fn is O, 6n is On square or not, yes, it comes in that class. That is what we discussed yesterday also, because we will be able to find, if I keep 6n as fn, we will be able to find c such that c and n0 such that it is less than or equal to c of n square, c into n square. When we write the big O notation, big O, we will say that 6n is actually On. But if you ask whether 6n will fall in On square, yes, because you are able to find c and n0 correspondingly. Okay, so that's what. So you see these f1, f2, f3, f4. If you want, you can make a note somewhere, because we will repeat these functions again in the coming slides as well. f1x is 3n square, f2x is half n square plus 100, f3x is n square plus 5n plus 40, and f4x is 6n. All right. So now OGN is the set of functions. We already defined this. So generally we are most interested in big O notation, since it is giving you an upper bound on the running time. You say that running time cannot grow more than this. It is going to be equal. It is going to be equal to this or less than this. So this is giving you an upper bound. This is what we are actually interested in finding out. Big O of a function. Okay, but is there a concept of lower bound also? Yes, there is a concept of lower bound also, that is represented by omega. Omega gn is a set of functions. Omega gn is equal to fn, right? So for, if you want to find out if a given function fn is given to you, such that there exists positive constant c and n0 again, such that c gn is less than or equal to fn. Right? So we are able to find C and N0. The conditions are same, that C and N0 has to be positive constants greater than 0, but CGN is less than or equal to Fn. So this is giving me a lower bound. Okay, that means lower bound means Fn will grow at least this much, right? Fn will grow at least C of Gn, but Fn can grow more than C of Gn also, because C of Gn is less than or equal to Fn. So that gives me a lower bound. So similar to upper bound, there is a case, you can say, that you can call it as lower bound as well, but not very much important, because we are trying to find out the upper bound for a function about its performance. Okay, but we can bound the function fn below by some constant factor of gn, right? So these expressions are same now. Now if I say f1x, f2x, f3x and f4x, same expression, 3n square, half n square plus 100, f3x is this. In the previous case, we had taken it as f4x, we had taken as something with n, 6n. Now we are saying f4x is 6n cube. Okay, so now the question is, can I say for all these Fn, is it omega n square? Can I say that 3n square is omega n square? Can I say half n square plus 100 is omega n square? Can I say n square plus this is omega n square? The answer is yes. Why? Because it is important that I am able to find a C and a corresponding n0. Now, if you want to prove that, you saw that if f1x is 3n square, you saw that it is on square also and omega n square also. But the corresponding constants are going to be different, right? Because if we are seeing the lower bound, it will not work with the same C and same L0. So there will be different constant C and different constant L0. That is going to make sure that 3n square is omega n square, right? Similarly, all this is going to be true. Now, what about this? 6n cube. Then I say 6n cube is omega n square, right? So if I only give you this expression 6n cube, and if I ask you to find out the lower bound, then the lower bound is going to be n cube only, right? Because you will say that it will grow equal to n cube, right? Or it can grow more than that n cube. So if fn is 6n cube, the idea is lower bound is n cube, means at least n cube, the growth rate will be at least n cube. But it can be more than n cube as well, right? So if something is more than n cube, then obviously it is more than n square also, right? So you must understand that. So if something is more than n cube, obviously it is more than n square. It is going to be more than n as well. Though we do not write it like this. If it is 6n cube and if I ask you to find out omega, your answer should be n cube. But if the question is asked different way, do you say that 6n cube is omega of n square? Yes, because we are able to find corresponding C and n0 to satisfy this condition, right? So that is about the lower bound. Then we talk about theta. Theta is another notation that combines upper and lower bound. So theta tells you about upper and lower bound, but as we discussed before also, now if you want to say that something has a lower bound and something has a lower bound with the same function and upper bound also with the same function. Now if I want to say that 3n square is O of n square and omega of n square, I should be able to prove with different constants. Sometimes this constant can be same as well, but generally it is not, it won't happen, right? So you need to choose two different constants. You will have different constant, C1 and C2 you can call them. For one thing you can say that the growth rate is so growth rate has to be equal to that. So one thing will give you a growth rate, which one constant will give you a growth rate which will always be less than Gn. Another constant will give you a growth rate that will always be greater than Gn. So that is what it is. But your n0 it has to be same. Okay, so theta Gn is equal to Fn. Fn is such that, okay, so you call it as, if it is given that theta of Gn, then Fn is in class theta of Gn if there exist positive constant C1, C2 and N0 such that 0 is less than equal to C1 of Gn, is less than equal to Fn, is less than equal to C2 of Gn. Right? So you need to find out now. So the meaning to say this is it has to be C1 and C2 has to be constants which are greater than 0, and for all n is greater than equal to n0. N0 has to be constant, common now. Okay, so N0 is, it is not that I have a corresponding to this C1, I have one N0 and corresponding to C2, I have another N0. No. So N0 is going to give you the minimum number. Okay, the number equal to that or greater than that whenever you have input size of that capacity, the condition is going to satisfy, right? So this is important here. So we are saying that we can bound the function fn above and below by some constant factor of gn, right? Though these constants will be different. It is not possible that you are able to find the same constant. Okay. So that is your theta. Okay. So a function is theta bounded if and only if. function is theta bounded if and only if it is big O bounded and omega bounded. So to prove that Fn is equal to theta of Gn, you have to prove that Fn is equal to O of Gn and Fn is equal to omega of Gn. Both things we need to prove. So all right, so now you see that I have changed the function 4. Now we are saying that if Fn is all this, we can call it as theta of n square. We should be able to prove that. This is very simple to prove. F1x is 3n square. You call it as theta of n square because you should be able to find out C1 and C2 and n0 such that this condition satisfies. Right? So 3n square is theta n square. 1/2 n square plus 100 is theta n square. N square plus 5n plus 40 is theta n square. Now we see this part. F4x, now we have said it as 3n square plus n log n. Okay, you should be able to prove that yes, you are able to find C1 and C2 such that this is On square as well as omega n square. All right. So now let us talk about worst case versus best case versus average case. Okay, why I have put this slide is to say that don't confuse these three things with O, omega or theta, because the O, omega, theta, all three are asymptotic notation. Okay, they all are asymptotic notation about bounding a particular situation. But what is worst case, best case, and average case? Okay, worst case is to find out what is the worst case running time of the algorithm, right? How much time it will take in worst case scenarios. Best case is what is the best the running time of the algorithm can be. So first we need to find out what will be the situation that the algorithm takes minimum number of operations. That becomes my best case. And what about average case? Okay, average case means I am going to give a random data. And what is the running time of the algorithm? Okay, average case doesn't mean that I will give it all the inputs, all kind of inputs, and then I will take an average of it. Generally, by average means average gives an indication like that, right? Average gives an indication like that. I have the maximum limit of n is if it is 10,000, then I should give all the inputs and then I should calculate the time and then I should take an average of it. No, that is not the purpose, right? We don't want to do that. So average case is given random data. Any random data I give, what will be the running time of the algorithm? So for example, we had seen the case for finding the maximum element. One was the best case. Best case means the first element itself was the maximum element. Worst case will be the maximum element is, the worst case will be the array is in increasing order. And random case will be, something is given in the array. That is not the best case and also that is not the worst case. Okay, so given a random data, what is the running time of the algorithm? So for all the three cases, worst case, best case, or average case, you can, so in any situation, we are able to apply these three asymptotic notation, O, omega, and theta. Okay, so they are not, so we don't say that worst case is associated with O or best case is associated with omega, not like that. So these are three situations, but we always compute the worst case running time because we want to find out the upper bound, right? So we always try to find out, we always go for the worst case, but that also we can give, if we can find out with the upper bound, we can also find the lower bound and we can find both the bounds, lower bound as well as upper bound in any case. So what we do is we choose the maximum number of operation, that is my worst case. Right? Now this is a question for you, okay? So that 5n square minus 15n plus 100 is theta of n square. Okay, so basically to prove any bounds, what we need to do is we need to find constants that satisfy the inequality. So please have your pen and paper with you, students. Okay, I'm not asking you to, to tell me the answer, but if something is written here, if you are getting confused, you can always try it with pen and paper. Okay, so show that fn square minus 15n plus 100 is theta n square. So how do I prove? I will first prove that it is O(n) square, and then I will prove that it is omega n square. So first we will prove, step 1 is prove it is O(n) square. So I need to find the constant C and N0 such that this is my Fn, right? Fn is less than or equal to C of n square, C of Gn. For all n is greater than n0. N is greater than equal to, I can say here, n is greater than n0, let us say. Right? So for that, what do? I just simplify the equation. I say that this is same as Cn square is greater than or equal to 5n square minus 15n plus 100. Now I can divide it by n square both sides. So C is greater than equal to 5 minus 15 by n plus 100 by n square. Right? So what am I up to? I want to find out the value of C. Right? Can I find a minimum value of C? So now, so we just do trial and error. So let us say we are going to keep n0 as 1, that is n as 1. Okay, so if I keep it as 1, so what do I get? I get, and if I keep C as 5 plus 100, that becomes 105. Okay, so for example, if I keep n as 1, so I get 5 minus 15. 5 minus 15 gives me minus 10, right? Plus 100 divided by 1 square. 100 by 1 square gives me 100, right? So 5 minus 15 gives me minus 10 plus 100 gives me minus 10 plus 100 gives me 90, right? So basically what we are saying is C has to be greater than or equal to this. C has to be greater than or equal to this. So I am getting value of C as not 105. Can I get it as 90? I think 90 should be enough, no? If I make ns, students please do with me, if I make ns 5, so it is going to be 5 minus 15 plus 100 by plus 100, right? So it is going to be 105 minus 15. 105 minus 15 gives me 90. So if I keep C as 90, it is good enough, isn't it? Why? Because see, if so, I have taken a case that n is going to be 1. If n is more than 1, right? If n is more than 1, obviously this 100 by n square, the maximum value of 100 by n square is 1. It is going to be less than 1, right? And if I keep n as more, then also this place is also going to be less than 1. Okay, so what basically we have done here is, what we have done is we have done minus 15 by n. We have said that it is going to vary between minus 15 and 0, right? And this is also going to be very, very less, right? So I can as well keep my constant C as 90. Do you agree with this or not, students? That's why I have purposely written here 105. Right? So 105, why we have written here is, for the explanation for 105 is because 100 by n square only gets smaller as n increases. Okay, because it's the higher order term. To simplify, how to find out C, we said 100 by n square only gets smaller as n increases. And this is a negative term, we are going to ignore it because the value is going to be minus 15 and 0. So we say that C can be equal to 105. Right? But if I say C can be 90, is it good enough or not? You have to tell me, students. Can I take C as 90? Yes or no?
Ma'am, we have to take the maximum value of C, no, ma'am. We have to, since the expression is less than or equals to C n square, and the second term will be only decreasing it. So that's why they have ignored the second term. Like they are
Okay.
finding value.
Why? Because it is a negative term. That's why.
Yes, ma'am.
Right?
It will be
Okay.
decreasing.
Okay. So that's what. So I want to know from you. Anybody can answer that. Why we are not taking C as 90. Yes. So what? So explain it again, please, to everybody.
Ma'am. So this expression is less than or equals to C n square. We have to find a C such that the expression gets satisfied. After simplifying this expression, we get like C less than or equals to 5 minus 15 by n plus 100 by n square. This means that we are finding the minimum value of C. Like Not minimum exactly. The C should be maximum, ma'am. So
She
if
should
we are
be
taking,
greater, yeah, she should be greater than or equal to this, right? So you can consider
yes,
it as equal now. Yeah.
ma'am. If you are considering, suppose the second term is also exist, we will be getting a small c value. So the expression will get small. But there is also a possibility that the c is bigger. Like if you are ignoring minus 15, because minus 15 by n can become 0 also. Will be the least value will be 0, since we are
Okay.
considering the greatest value. Uh,
Okay. Okay.
so
So
then we
if
are
you mean to say, suppose I consider n as 15, right? You mean to say if I consider n as 15, for example, so it will be 5 minus 1, almost 1, right? Right? Or more than that, if you say it becomes almost 0, that's what you mean to say, right?
ma'am, like we are ensuring that we get a c value such that the expression is always less than or equal to c n square. Yes, no, ma'am. So if we are, if suppose the second term is exist, then if you are noticing the statement in the second step one, c square minus 15 plus 100 less than or equal to c n square, no, ma'am.
Correct.
So the left expression, uh, like I will be speaking about this only. The left expression uh, can be a small value or can be a bigger value. We will be considering the bigger value itself, since
Okay.
that will be less than or equals to cn square. So we are finding out when this can be the bigger. So
Okay.
15 n plus 100 less than or equals to cn square means n square minus 15 by n, sorry, minus 15 by n, oh, by n only, huh? Minus 15 by n plus 100 by n square less than or equals to c, no, ma'am.
Yes,
So
yes, yes,
uh, the maximum value of 5n square, the maximum we are finding out. So when we are
yes,
finding the maximum value, we are ignoring the negative value because it is only decreasing it. So the
yes,
maximum
yes.
value can be 5 plus 100. So I thought that's how this
Very good,
convert.
very good, very good. Yeah. So that is, so that's why I asked you, this question, student. So, yeah. So I hope you understood, student. So we have written it here. Cn square is greater than equal to. But if you are comfortable, you can keep it as less than or equal to Cn square only. So you want to make this thing as less than or equal to Cn square. Okay, so it should always be less than equal to cn square. So you are trying to find out the value of c that that always satisfies. Okay, that always satisfies. So we are taking the higher value of c. Okay, not only one case we are not considering, and negative value we are ignoring. All right, fine, good. Okay, so another question, so no, we have done only half. We have only done step one. Now we are up to finding out step two, right? To find out omega n square. So again, I need to find out the constant Cn n0 such that this inequality is satisfied. That 5n square minus 15n plus 100 is greater than or equal to Cn square. That's what we want to find out. So this is less than, this was, you were finding out less than Cn square. Now we are trying to find out this is greater than equal to Cn square. That means Cn square is less than or equal to 5n square minus 15n plus 100. Right? So that means again C is less than or equal to 5 minus 15n, 15 by n plus 100 by n square. Right? So now if you keep n0 as 4, okay, and c is equal to, if you keep 5 minus 15 by 4, you are trying to now find out the minimum value of c. Okay, or c, you get c is equal to 1.25 or anything less than 1.25, because 15 by n is always decreasing and you are going to ignore 100 by n square, because it is always going to be between 0 and 100. Now your condition is different, right, from the previous case. In previous case you were trying to find out c. I have written it this way, not the other way. So c has to be greater than or equal to this. You were trying to find out the maximum value. Now if you see, we are trying to find the minimum value of c for omega n square. Okay, so because your cn square, if you want to understand, greater than or less than thing, you can write it like this: Cn square is less than equal to this. So this gives you C is less than or equal to this. And you want to find out the minimum value of C. So that is why you are ignoring 100 by n square. Okay, so this you have to do some sort of trial and error kind of thing. So you are assuming, why did you do that? Because you assume that n0 is equal to 4, right? So if you say 4, what happens here? If you say it as 4, so because it is 15 by n, right? And you know that 4 4s are 16, right? So 4 4s are 16. If you do 15 by 4 here, you know that it will be something like 5 minus, suppose it was 16, so it would have become 5 minus, if it was 16 it would have become 5 minus 4, that would have given you 1 here, right? 5 minus 4, it would have given you 1 over here. 1 plus 100, this term you can ignore, because this will be between 0 and 100. Because if you keep n is equal to, maximum is going to be, if you keep this, if this n square is 100, let us say, so you are going to get the value as 1, or the minimum value you can get is 0. So the meaning is it cannot be more than 100. 100 by n square cannot be more than 100, and we are up to finding the minimum value of C, right? So we are ignoring this, and from this term we are getting C is equal to 5 minus 15 by 4. So that is going to give me 1.25, or which is anything which is less than 1.25. Okay, because 15 by n is always decreasing. Okay, so this is how we prove we get the value of C, and we also get the value of n0. Okay, so certainly we saw here in this case when I wanted to prove that it is theta n square, right? So I consider n is greater than n0, and I selected n0 as 1 here, right? If I select n0 and as 1, and then I found out C. And here what we did, here also we selected n0, and my n0 I said let it is going to be 4, right? So what will finally be my answer? So can I have different n0 for omega and O? So what will be the value of n0 if you want to keep the same n0? What will be the value of n0? What should be n0? Okay, so let us say, I'm not trying to confuse you students. So let us see, why did we take n0 as 4? We took n0 as 4 because we wanted to get the value of C. Now, we'll just check it like this. Will this satisfy when n0 is 1? Will this satisfy when n0 is 1? Okay, so suppose if I am keeping C as 1.25 and keep this as 1, keep n as 1. Okay, and tell me what will be the answer. 5 minus 15 by 1. 15 by 1 will be, 15 by 1 is going to be, let us say it is going to give me minus 15. 5 minus 15 is going to give me, 5 minus 15 is going to give me minus 10. Minus 10 plus 100 by, so plus 100 by this value is going to be 1. Minus 10 plus 100, that is going to be 90, right? So even if you keep n0 as 1, you are going to get this inequality satisfied. All right? C is less than or equal. So this n0 equal to 4 we took for taking an example which was to find out the value of C early. Okay. Otherwise, if I can take n0 as 1. Okay. So what I'm trying to say is, see this definition. Where is the definition of theta, right? So I can find out two different constants, C1 and C2, for all n is greater than or equal to n0. Okay, so I can keep my n0 as 1 only. Okay, I need not change the n0. So why we took two examples, one with 4, to simplify finding out the constant. All right, so I can find out two different constants, C1 and C2, for all n is greater than equal to n0. See, we do not say anywhere that it is n is greater than equal to n1 and next time n is greater than equal to n2. We are not saying the two n0s. So n0 has to be 1. Okay, so that's it. So once we are able to prove this, that means we have proved that the given function fn is theta of n square. Okay. So now the next question is for you, that all of you know that this is not correct. Is fn square on? All of you will answer that it is not. No, fn square cannot be on. How do I have to prove it? Right? So to prove that, we have to say that we are not able to find a corresponding constant. We had done this. I had told you in the very first class also. Okay. So now if we want to prove it theoretically, we will say, we are trying to understand how to disprove the bound. Okay. So we will first assume that it is true. We will assume that it is true. So because if it is true, that means there exists some c and n0 such that we should get this thing. 5n square is less than equal to c of n for n is greater than n0. Obviously, we will not be able to find such constant. So then we will get 5n is less than equal to c. Right? So it is not possible, because when you say 5n is less than equal to c, that means c has to be a constant. Now, if you keep changing the value of n, right, every time this may not be possible. You have to fix a constant. So you cannot keep on changing the constant, right? And you cannot say that I am going to take the constant, the infinite, no. You cannot say that, c can be some value such that fn is always less than or equal to c. No. Okay, so this is a contradiction by which we can disprove the bound. All right. So now we will just, see some rules of thumb. Okay. So this is kind of, you can say, this is a revision of what you have learned so far in your algorithm analysis. Not here, not only here, in your previous course as well. Okay, so let us see. Then I will ask a quick quiz to you. Okay, quick quiz means I will give you some 4-5 questions and one of you have to answer. Okay, so multiplicative, so just be attentive, okay, because quickly one of you should answer. Okay, so first thing is multiplicative constants can be omitted, right? So 14n square becomes n square. That means O of 14n square becomes O of n square. Similarly, 7 log n will become log of n. Then we have seen these rules before also. Lower order functions can be omitted, right? So n plus 5 will become n. N square plus n will become n square. Okay. Now this is nice, important rule. N to the power a. Both are polynomials. N to the power a dominates n to the power b if a is greater than b. Simple, right? N square dominates n, right? So n square plus n will become n square, right? You know all these rules. Similarly, n to the power of 1.5 will dominate n to the power of 1.4. Okay. Then another rule. This is exponential now. A to the power n. So you must understand the difference for your revision. N to the power of something is called as polynomial, right? And a to the power, where a is a integer. Okay, a is a number. A to the power n is a exponential. So it is called as an exponential. A to the power n dominates b to the power of n if a is greater than b. So what is common here? Because n is common here. Because if a is greater than b, obviously a to the power n will be greater than b to the power of n. For example, 3 to the power n will dominate 2 to the power of n. Okay. Now the next rule of thumb: any exponential dominates any polynomial. Any exponential. Okay. It is not that it's a lower order exponential. Nothing like that. Any exponential is going to dominate any polynomial, right? To the power of n, right, dominates n to the power of 5. So because the rule is very simple. If for the higher values of n, this is going to be 3 to the power of, let us say, 10,000. Dominates, it is going to dominate 10,000 to the power of 5. Okay, any exponential dominates any polynomial. This, generally till this pandemic had not come, right? So we had only learnt it in theory that, this is the exponential graph, this is this graph, But after this, we actually realized, at least I don't know about you because you are very young. I actually realized this only after this pandemic. Okay, we really saw in real life, okay, this is the exponential graph, this is the meaning. Okay, why they are calling it as exponential graph, or what is the plot basically, how they are plotting it, right? Before that, all this was in theory. Yes, we used to remember. Now we actually know, everybody, maybe the school kids also know now exponential growth, what it is, all that we have understood now, right? So any exponential dominates any polynomial. So c to the power n dominates n to the power 5. Similarly, 2 to the power n dominates n to the power of c, where c is a constant. So this is a polynomial and this is an exponential. Then any polynomial dominates any logarithm, any polynomial. Okay, so n always dominates log n, or n dominates log of log n. Okay, n square will dominate n into log n, because it is n square, 2 powers of 2, it is n into log n. Also, n to the power of half will dominate log n. So that's why it is written any polynomial. N to the power half is also a polynomial, though it's under root of n, right? But it is a polynomial. N to the power half will dominate log n. Okay, so these are some rules of thumb. Another important rule: do not omit lower order terms of different variables. Okay, so you cannot. So if n square is a variable, also m is a variable. So generally, what we have seen is in all our algorithms, in all our generally, we don't come across this situation. In the sense, when we write the computational cost, or when we write the computational cost of any algorithm, generally we put it in terms of the input size, right? So what is my input? And generally what happens, I have only one input, right? So if n is the number, so if I want to do a sorting of numbers, n is the number, n represents the number. But in real life that may not happen, right? There can be more input variables, right? Now all of you are doing your project, so you should be very well aware whenever you do your project, you must know that, okay, what are the inputs to my framework, what are the inputs to my algorithm that I'm going to implement. So there will not be only single input, no? So sometimes you have one set of input. Most of you are doing machine learning kind of projects. So if you do that, you have a whole data set. There are various inputs, right? So all those inputs are going to make a part of your algorithm complexity if you want to do that. Okay? So for example, I may have a complexity like n square plus m, where n is a different input and n is a different input. You have to consider both. So in that case, right? So do not omit lower order term of different variables. Because n and m are different variables, you cannot say that n square is going to dominate m. M square can dominate m, but not n square. Okay, so this is important. So maybe we do not use it in the kind of problems or computer science problems that we actually deal in this course. Whatever we learn, you will always find only one variable, n square. But what I'm saying is, all of you are doing your projects, right? Whichever project you are doing, it's very difficult to do, algorithmic analysis for those projects. But sometimes, that is also needed. Okay, so you write a very good paper. For example, you have done a very good work. Okay, everything you have presented it very nicely. They ask you send to a conference or to a journal. They ask you what is the complexity of your work. Okay, have you compared it? It is a very, very general question, students. If you see good research papers, they will always ask that, did you do the analysis of your algorithm? Okay, so you use it's little difficult also because there are various inputs involved. But it is not that it is not doable. So some assumptions. So we can always do algorithm analysis for any project that we are doing. Okay, what will be the computation cost? Because we are not restricted only to our textbook problems, right? All of you are going for some industry, some internship. Suppose you want to really understand that what will be my algorithm, how it is going to perform. So I should consider all the variables, all input variables, and then I should be able to, of course, there will be assumptions. We will find out, okay, this can be ignored, that can be ignored, but there will be some variables which are really playing part in making your algorithm. You need to consider all of them. So in that case, we are not going to do this thing. Okay, so in that scenario, you can understand what do you mean by this. Do not omit lower order terms of different variables. Okay, so yes, so now we are coming to a quick quiz. Uh, I don't want to see the names and then say that okay, you answer like that, but anybody can answer. Okay, any one of you can answer. Don't feel lazy in answering. I know almost all of you know the answer, so don't feel lazy. Okay, so you should behave like school kids. School kids cry that ma'am did not give me a chance. Okay, so everybody is doing online classes. So they are the kids will be very upset. They are ready to answer, but they did not get a chance. So they are very upset. They wait for their chance. So let us be like that. Okay, school kids. Okay. So yes, please say the answer. First question. Okay, what is going to be big O? N square plus n log n plus 50. Whatever rules we have learned so far, we have to quickly apply them. Anybody can answer. Yes?
Square.
N square. Very good. You say your name also, please. Hmm?
Vishnu.
Vishnu. Good. Very good, Vishnu. Yes. Yes. So Vishnu got some 5 points. Vishnu. Okay. 515. Very good. Okay. So the next question. 2 to the power n minus 15 n square plus n cube log n. Yes.
2 power n.
Yes. Please say your name also.
Priya, ma'am.
Priya. Priya, you explain why it is 2 to the power n.
Because any exponential dominates any polynomial, and here we are having n cube log n. So we can ignore that as well, because log n is anyway less than is not dominating as compared to n, ma'am. So even if we take n power 4, it will be a like uh, polynomial function.
Okay.
So
Very good.
exponential
Good.
will be dominating the polynomial or
Good.
logarithmic.
Very good, Priya. Very good. Okay. The next question, those who have answered, they will not attempt. Okay. Vishnu and Priya will not say now. Okay. The next question, n to the power log n plus n square plus 15 n cube. Okay. N to the power of log n plus n square plus 15 n cube.
N power log n.
N power log n. Say your name.
Dhruvan.
Dhruvant. Okay. So why is it so? Dhruvant, right?
Yes, ma'am.
Yes, Dhruvant. Why so?
When we consider large values, log n will definitely be greater than 3, ma'am.
Log n will be greater than 3.
Yes,
Okay. Anybody wants to contradict him? N to the power log n. Now it's like so all of them are polynomial, right? Dhruvan, you don't switch off your microphone. Okay, I want you to have a discussion also. So the thing is, now all of them are polynomial, right? So now the competition is between log n two, it is like all of them are polynomial, right? So it is n to the power a and n to the power of b, right? So who wins? If a is greater than b, that is going to win. So we need to find out whether log n 2 or 3, which is more. So you are saying that for large values of n, log n will be more than 3.
yes.
Anybody is contradicting Dhruvan?
Ma'am, I think NQ dominates N for log n
Why?
uh, because powers of integers dominates log n is a small value. Uh, I think like that.
No, but he said that if n is very, very large, see, it's like
Yes,
competition among the polynomials only, no? Right? So now
yes,
for the
ma'am.
large values of n, so let us say large values
Thousand.
of n means, let us say you can take 1024 also.
Okay.
1024 because log is on base 2, right? So 1024, the answer will be 10, right?
Yes,
So
yes,
for
ma'am.
large values of n, yeah, but we are seeing, so when we do the complexity, we do it for large values only, no? right? So anybody wants to contradict, say, because I also feel that what Dhruvan is saying is correct, n to the power log n, because the competition is between whether 2 is greater than, 3 is greater than, or log n is greater, right? So let's ask ourselves, okay, for large values of n, obviously log n will be more, right? So so log n will start becoming more when this becomes 3. So if you say log of 8, for example, log of 8 is going to be 2 to the power of 3. Log of 8 is going to be 3, right? So when n is equal to 3, that time itself you will find out that it has become same as n cube, isn't it? Right? So log of, if you say log of 8, if you make it, it becomes log 8 is becoming 3. So it becomes n cube. So I also feel, yeah, that is the correct answer, Dhruvan, that n to the power log n is the dominating term here. Okay. Anybody still wants to contradict? See, we need to get convinced, or else we should contradict for that. Okay, fine, Dhruvan. So you also get 5 on 5. Last question, who wants to get full marks? N to the power 5 plus n factorial plus n to the power factorial of n plus n to the power of n.
N to the power of n.
Who is that?
This is Vikas.
Vikas. Okay, Vikas. So I also feel that is correct. Yes, because if not n to the power n, the other term is n factorial of n. Factorial of n is nothing but n into n minus 1 into n minus 2. Again, you are going to get it as yeah. So again, you are going to get it as n into n square, like that. N to the power n you are going to get, right? So now the next question is it same? Is it factorial of n and n to the power n? Are they same?
No,
Because they are not
no,
same. Why?
no, ma'am. Suppose n factorial in the sense we are multiplying with the decrement numbers, but n we are multiplying with the same numbers. Obviously, suppose it
Very good.
will take
Very
10.
good. Good. So you also get 5 on 5, Vikas. Very good. All right, students. So that is the end of the class, end of the session for today. We'll continue, students. We'll continue with some more examples. Okay. And we will have. I have kept a slide. You can see here runtime examples. We have also seen here. We will also discuss all this in the next class. All right. Thank you, students. Thank you very much. Yes. Have a good day. So we will meet only on Monday now. Yes? Yeah.
Ma'am.